Okay, let's continue with this approximate formulas for calculating areas and volumes. And this means the situation when we mostly have some kind of figure there or area which has not any specific form. For example, it is not a rectangle or not a square or not a circle, but whatever. And you need to calculate the area closely enough for the correct value. And I think the best formula, in my opinion, is the Simpson rule. This is a Finnish formula book, and I will write the formula there in English form. And this picture tells something what we are going to do. I will take an example immediately so that we get something to calculate. This picture tells that we have to calculate the area of this gray area here, and we do it so that we divide it by subparts or divide it in parts, so that every part is equal in length or width, and the amount of these parts, the number of these parts are always even number. So it means that you need to have 2 parts or 4 parts or 6 parts. If the case is so, you may use the Simpson formula there. And let's take an example. For example, if we have here some kind of coordinates there, and we have some kind of area there, let's take it like this, and we want to calculate the area. We know that in the left side the height of the figure is, let's say it is 3 meters. I take easy numbers there. And in the right hand side the height of this figure is 5 meters. And we are using the Simpson formula, and there we need to divide this at least to 2 parts. So I will cut it in the middle from this. I think this is in the middle point. And let's think that this height here, well, this is, I only guess the values for, but let's take this height. It is 4.2 meters. This picture is not necessarily correct, but those measures may be like that. And then we have these lengths here. Those have to be equal side, and for example, if this is a 6 meter, then this will be half of that, so that those will be 3 meters both. And the formula for this area, Simpson rule, or rule of Simpson, I will first write in this example so that we have only 2 parts of the area, 1 and 2 there. And the notation for this is S like Simpson, and there are two parts there. And the formula is, I will write it like here, h divided by 3 y0 plus 4y1 plus y2. This is a very easy formula for approximate area of this figure. What does these figures there or those letters there mean? This h means the breadth of this one part. So this is h. This is also h. So in this case the h is 3 meters. Yeah. And these y's here, y0, y1, y2, they are the heights of this figure. This is the y0, this is the y1, and this is y2. This is y0, y1, y2. So I will write those numbers there. So now the h is 3 meters, y0 is also 3 meters. It's just the coincidence, those happen to be the same lengths. y0 equals 4.2 meters and y2 equals 5 meters. So this is all we need to know. Oh, sorry. So if we add those numbers to the formula, we get 3 meters divided by 3. This is always the number 3 there in that formula. And then we have 3 meters plus 4 times 4.2 meters plus 5 meters. Well, in this case, this first division there gives only 1 meter. There, I will take the calculator. So this 1 meter is the first part there, and then these brackets here, I will open them. 3 plus 4 times 4.2 plus 5. 24.8. And this is meters there. So actually this is 1 times 24.8, so it is 24.8 square meters. This is very useful formula when you have a quite smooth border in this figure, so it doesn't go up and down. So, but it is quite smooth there, and in that case, this gives quite a good approximate for approximation for the area of this figure. We may check this. Does that seem reasonable? We got 24.8. If we think that this would be a rectangle with a height of 5, so it would be something like this, the figure, then the area would be 6 times 5, so it would be 30 square meters. So in our case, this figure is smaller than this rectangle, so the area must be smaller than 30 square meters, and as we saw, it was. And also, if we think that this would be this kind of rectangle, if we divide it in this height, so in that case the base is 6 meters and the height is 3 meters. 3 times 3 is 18 square meters. So the correct area is more than 18 square meters. So we can, from this picture, guess that the real area must be between 18 and 30 square meters. And as we saw, it really was with the help of this formula. Many times, or I would say surprisingly many times, this this formula is close enough to get good enough to get close enough results for the area of some strange figure which has not so any strict what is it, form. But as I said, if this borderline is quite smooth, this is a very good approximation. And many times this simplest version of the Simpson rules is well enough. But if there are some more, let's say, the borderlines is not that easy. Let's take example where we have area or figure which is, for example, like that. And there are probably best to, in this case, to divide it to more divisions. So in this case we had 2 parts there. Let's take the next possible count of areas or subparts there. It would be, as I told, this formula works only if there are even number of parts there. So 2 is the minimum. The next one is 4. So I will divide this area here to 4 parts. There are these parts here, and I divide. I use my ruler. I get the more exact picture. So now I have divided it to 2 parts, and I divided these both parts also to 2. This somewhere here. So now I have divided it to 4 parts. Let's number those parts. 1, 2, 3, 4. And now when we had two parts, we had to measure 3 heights. 1, 2, 3. And now when we have 4 parts, we have to measure 5 heights. 1, 2, 3, 4, 5. The notation is similar. Here we we use this notation that this was y0, y1, y2. So the index of this last one here is the same as the number of those subparts in this figure. It starts always with 0 and ends with the same index, which is the amount of or number of those parts there. So in this case here, this height is y0 and this last one is y4, and then y1, y2, y3. Well, now when we have more subparts there, we can't use exact the same formula as here, because there are two more parts there. Oh, sorry, two more parts and also two more heights from the figure we had to take. And I will show you the formula from this book. As you see, there is the start of the formula is the same. H divided by 3. It is always the same. H is always the width of the part of that figure. And if you watch those y's inside of brackets, we see that it starts with the same way as in the simplest form of this Simpson formula. Y0 and 4, y1. We had the same here. And from this end of this expression, there is also the similar part. There is yn. N means the number of parts there, and if we have 4 parts now here, so the last one is y4. And if we have 4 parts there, the next height before the last one is y, and here index 4 minus 1, it equals 3. So this is y3. So there is y4 in the end of and y3 in the earlier term before the last one, and the factor in front of that term there is 4. So how do we build this formula? I will draw it here as I used to do. So these parts here are always same width, h there. And now when we want to calculate Simpson formula for 4 parts, S comes from the word Simpson, and 4 means how many parts you have in that figure. How many subparts have you divided that figure. And we also always have this h divided by 3 every time in that formula. And now I will do this with the mechanical way. I do have there these heights. I will write them there. y0, I will leave some space there. y1, y2, y3, y4, and then we are building there some factors in front of these letters, and we are summing here. We also had sum or addition there. Here again we have plus signs, plus, 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 and then we take first and last. They get the factor 1, so we don't need to write anything there. There is simple y0 and y4 there. Then we go to the next one. This finger moves to the right and this finger moves to the left, and we get the factors for these letters, and it is always 4. So here is 4 and here is 4. And after that it goes alternating 4 or 2. If you watch this universal formula there, 4 2 4 and 4 2 4 2 4 2 4 2, it is always either 4 or 2 inside of this sum expression there. So when we close when we enter to the center of this expression, we have nothing or 1 for the factor. Then we have 4, and the next one is 2, and both fingers come to the same letter, and here we put 2. So this is the formula for 4 divisions or four parts. Well, it doesn't look so nice. I will write it a more clearer form. y0 plus 4y1 plus 2y2 plus 4y3 plus y0. And if I will use my ruler and I will measure the lengths of here. Unfortunately, you probably have not, if you draw this picture on your paper, probably you didn't get the exactly same figure, but I will. Most important is the values I get here. In this case, we have the age here. Let's say it is 2 meters. And then these heights there, I will measure them with my ruler. This would be 3.9 meters, so y0 is 3.9 meters. How do I do it? The next one will be y0, it equals 4.7 meters, and then 4.4 meters, and also y3 equals, what is it, 3.8 meters, and the last one, y4, is about 5.2 meters. So now we have enough measurements. We know the breadth or base of these figures. It is always the 2 meters here, and then we have measured these heights there. And now we add those to the formula. always when you use this Simpson formula, check the expression that it went correct. It should be symmetrical, so that if you start from left part or left side and right side, and you move to the center, you should get the same factors there. So these numbers, they don't have any factors at all, or those factors are 1. Then we move here, both have 4 as a factor, and then here we have the 2. So this is symmetrical. It is some kind of mirror image if you only watch these factors there. And then we may calculate the value of this area. I will use the other calculator. You may see the process there better, or then not. Yes, I think you may see that here. I will calculate this in one part only. So here is my result, and the unit of this area is square meters, because there were meters used in that calculation there. Well, of course, you may round this number. Well, if we think that we got these measurements, well, of course, I think if this area would have been in the outside there, and I would get a measure ruler with the help and do the measurement with the rulers, which would be long enough to get these kind of measures. I think usually I would measure those more correctly. This is only the precision of 10 centimeters. I think mostly we can measure that length in the precision of centimeters, or even more precise. For example, in the precision of or accuracy of millimeters. But in my problem now, I have made those measurements actually in the 1 decimal accuracy when unit is meter. So and this measure here, let's think that this is 2.0. So there are also 2 figures in all measurements. So that would mean that the rounding of this answer should be rounded to 2 figures. So 2 first figures is there, 37, and it stays. So it is 37 square meters. If we try to check from the picture, my picture is now drawn so that these measures are quite good measurements. But for example, if we take a maximum area, it would be area where we would take the highest point of that figure, and in this case it would be the y1. So if we think that this is this is a rectangle, which is this kind of worm. So the area of that figure would be less than, this was 2 meters, so the total width was 8 meters, and the longest height or biggest number in these heights was 5.7. So the maximum area would be 8 times 5.7, 45.6, and we had a smaller number there, so it sounds reasonable. And the minimum area would be if we choose the smallest or smallest number of these heights there, and the smallest number is 3.8 here. So that means that we would think that the area would be this kind of rectangle there. And if we calculate that, so this was the maximum area, and the minimum area would be 8 times 3.8, 30.4 square meters. So as we see, this is okay. It seems quite reasonable to get this kind of value. And this could be used also, this formula for subdivision for to 6 parts or 8 parts or 10 parts, etc. And usually we get more exact answers to the area if we use more subparts there. But in my experience, I would say that in most common or everyday situations where you need some kind of approximate area for figures like that, these 4 parts is mostly enough. No, there is, of course, you may get a more precise answer, but the time to calculate it gets every time higher and longer if you are making more subdivisions there. This is mostly well enough. Okay, I will now give you some problems. I will not continue my lessons, but I will give you some problems to answer. So there is, unfortunately I can't get a good picture of that. Well, now maybe you see. There are problems concerning these figures we have had today and yesterday, and here in those problems there are 5 problems there. There are some are quite easy to use with those formulas we had and what you have in that Moodle page. But some are a little bit trickier, not a very hard one, but such that you don't find the easy formula. You have to calculate more something to get the possibility to use those formulas. And I will leave these to your exercise now for the last minutes of this lesson. I will stop my speaking, but I will wait here and check your answers if you get answers. I suggest that if you will stay in this Teams session, if you get answer to these problems, every time you get answer, write your solution, not necessarily the solution, but the answer of the problem to the chat box, so everybody can compare their answers there. And of course, if I see someone writing answer there, I will tell if that is correct or not. But actually I have to calculate those problems also myself, because I wrote those problems during the break. But actually this is everything today. For today we will continue. By the way, I wrote this title here, approximate formulas for calculating areas and volumes. I will take that volume part later. It takes a little bit time, so I don't want to be in too much hurry, so that we will take later. But in this example we had only those area problems, or Simpson formula for area calculations. So I will end the recording now, and I hope you can start your solving these problems.